Hello everyone, in this video I'll be solving one coding problem from Leetcode. This is going to be a part of competitive programming series on my channel, where I will show you how to approach a competitive programming problem. Also, while solving the problem, we will start with the naive approach and then we will try to improve the solution to get the optimal solution for this problem. Okay, this will also help you to crack any coding interview. So if you are ready to enhance your skills in competitive programming, please don't forget to hit the subscribe button. Let's start with this video. Here I am on Leetcode website. If you don't know about Leetcode, Leetcode is a programming platform similar to HackerRank, HackerEarth or CodeShape. Today we are going to find the duplicate number problem. So let's see the description of this problem. Given an array of integer nums containing n plus 1 integers where each integer is in the range of 1 to n inclusive. There is only one duplicate number in nums, return the duplicate number. So according to problem statement, we will have an array of numbers where we will have n plus 1 integers and it will be in range from 1 to n, and we need to find the duplicate number from this array. Okay, so let's scroll up. So here in follow-ups, it basically tells you how you can improve your solution. So we'll talk about this in the later part of this video. I'll skip this now. So here we have few examples. So for example, if you have this input with these numbers 1, 3, 4, 2, 2, then the output will be 2 because 2 is duplicate here, right? Similarly, in the example 2, we have this array where we can see that 3 is the duplicate number. So here you can see that they have given few examples so that we can understand the problem statement correctly, right? So here we are clear with the objective, right? What we are trying to find. So if you scroll a bit, you will find some constraints. So constraint basically tells you about the range of your input. So here for n, it lies between 2 to 3 cross 10 to the 4. That means your number of elements in the array will be minimum 2 and maximum 3 cross 10 to the 4. Similarly, nums.length tells you the number of elements in the array. That means if your n is 5, your total element will be 6 in the array. That means you will have some duplicate elements, right? Also, it tells nums of I will lie between 1 to n. That means any value in the array will be between 1 to n. That means if you have this value n as 5, then you will have values between 1 to 5 only. It cannot be 6. Okay. So now the fourth constraint is all the integers in the nums appear only once except for precisely one integer which appears 2 or more times. That means, for example, let's say this array, right? So it is saying that it can have a duplicate number and this duplicate number can be 2 or more, right? Here it is saying which can appear 2 or more. That means here you could have also 3, 1, 3, 4, 3, right? Then also you have to give this output. So that's the gist of this problem. Now we'll see how we can approach this problem. So we'll start with the naive approach and then we will see how we can improve on the solutions. Okay. Next, I will show you the different approaches to solve this problem with the different time complexity, and we'll see the code for the optimal solution. Okay. So let's go to our IntelliJ. Here I will show you the first approach where what we will do, we will simply compare each element with the others and we'll see if any duplicate occurs or not. If it matches any other number, then that means that's a duplicate number and we can return it. So we can say that in first approach we will be comparing each element. So for example, let's say we have this array and here you can see that we have elements 5, 6, 4, 1, 3, 2, 4 and here 4 is the duplicate one. So what would be the naive approach to solve this? I'll simply run a nested for loop to compare each element. So for example, let's say if I have a nested for loop with variables I and j, I'll compare 5 with 6, then 4, then 1, then 3, then 2, then 4. So it does not have any match. That means this is not the duplicate number. And similarly, I'll be comparing for element 6 and again there is no match. Then again I'll increment I with 1 and I'll again start the same traversing. And here for this 4 element, I'll get a match. That means this is our duplicate element and we can simply return this. So now we'll see what is the time complexity for this particular approach. So here, as you can see in this approach, we have to have a nested loop where we have to compare each element with others. That means here the time complexity would be order of n square. So I hope the first approach is clear. Here the time complexity is order of n square. Now we will see the second approach. Here we will simply sort the array and then find the duplicate. So how we can do that? So for example, let's assume that we have the same array and then the first thing we will do, we will simply sort this array. So after sorting, we will have something like this: 1 2 3 4 4 5 6. Okay, so next what we need to do, we can simply run a for loop to check if there is any duplicate number. For that we can have two pointers. So here I'll iterate through this array and I'll compare I and I plus 1. As we know that this array is sorted, that means if there will be any duplicate number, they will be adjacent to each other. So similarly, we can keep incrementing this I pointer, so that at this point we will have at I we will have 4, and at I plus 1 also we will have 4. That means we have a duplicate number and we can simply return this value. So here if you calculate the time complexity, the first thing we did is we sort the array. So now assuming that you have sort this array with the base sorting algorithm, for example merge sort, and then for finding the duplicate element we need one iteration, that will take n time, right? So overall the time complexity would be n log n. Now we will see the third approach where we will be using the frequency array. So here what we are going to do is we will be keeping a frequency array to basically keep a counter of the number of elements in the given array. Okay, so for that let's assume that we have the same array available here, and then we will keep a frequency array where I'll initialize everything with 0. So initially the count for all the elements will be 0. So as we know, for this example the value of n is 6. That means the number in this array will lie between 1 to 6 with one extra duplicate number. That means overall it will have 7 elements, but the number will lie between 1 to n, that is 1 to 6 for this example. That is the reason you have to keep your frequency array of size 7, so that you can map the frequency from 1 to 6. Okay, so I'll tell you what you need to do. So you simply have to iterate over this array. So for example, let's say if you iterate through this array, first you will get 5. So at index 5 you will simply increase the count. Okay, and then similarly for element 6 we will increment the value at index 6, and similarly at index 4 we will increase the count, and similarly we will do it for 3, and then 2, and then again we have this 4. So when you come at 4, index 4, you already see that it has a value 1. That means, so basically you need to check if this value is 0 or not. If 0, then increment. If it is more than 0, then what you can simply say is that this particular element is a duplicate element. So you can simply return the index of this particular field. So here it becomes 2. Now we can simply say that the element 4 is the duplicate element inside this array. Instead of using array data structure, you can also use hash map or set, okay, with a similar logic where you will simply keep a count of these elements. Okay, so let's identify the time complexity for this approach. So as we see, we iterate over this array only once. That means the time complexity of this approach would be order of n, but here we have used an frequency array which is of size n plus 1. That means we have a space complexity of order n. So overall in this third approach we have a time complexity of order of n, which is a good number, but we also need a space of order n, which is not that good. So we'll try fourth approach where we'll simply use the tortoise method or cycle detection method. I'll tell you what it is with a proper example. So for that we have to go to a presentation mode. Here in the fourth approach I'll be using a popular method called tortoise method or cycle detection method. Okay, I'll show you what it is. So let's understand, we are taking the same array input here, and then I have also mentioned the indexes here over here. Okay, so the idea here is that we will be traversing this array in such a way so that we can identify the duplicate elements. So I'll tell you how we will traverse. So here the traversal will look something like this. You will start with the first element, which is 5, and then you will go to index 5. So here at index 5 the value is 2, and then at this point we will go to index 2, and then at index 2 we will see what is the value, and similarly we will go to index 4, and then again at index 4 we see the value is 3. So next time we will go at index 3, and then in this way we will simply traverse to identify the duplicate element. So I'll show you how it looks when you traverse in this fashion, where you are simply moving to the indexes of this particular value. Okay, so let's start with the first element, which is 5, and from here you will move to index 5 and you will see this value. 2, and similarly at index 2 you have 4, and in the same way for at index 4 we have 3. Similarly at index 3 we have 1, and then at index 1 we have 6, and then at index 6 we have 4. That means here you can see that we are getting a cycle, right? When you traverse in this way, you will always have a cycle if you have a duplicate element. So now we know that we will always going to get a cycle when we traverse in this way, because we have one duplicate element in the array. Now next we will see how we can identify that we have this duplicate element present. Now for traversing this array, we will use two pointers. We will call it a slow pointer and a fast pointer. Why we call it a slow pointer? Because every time it will move only one step, whereas the fast pointer will move 2 steps. So let's try to see this visually. So both will start with the first element 5, and then after that the slow will move to 2, that is 1 step, and the fast will move to 4, that is 2 steps. And similarly next slow will go to 4 and fast will go to 1, and next slow will go to 3 and fast will go 2 steps, which is 6 and then 4. So fast will come at 4, right? And again slow will go to 1 and then fast will also come at 1. This is where the first collision occurs, okay? So whenever you see your slow pointer and fast pointer are pointing to the same value, you have to stop here, and then you have to move one of the pointer at the start point. That means it will look something like this. So after this collision point, what I did, I moved the fast pointer at the starting point. And now from this point onwards, both the pointer will move only one step. Okay, that means S will move to 6 and F will move to 2. And similarly, S will now move to 4 and F also move to 4. So this is where the second collision happens. So here in the second collision, we can say that this is a duplicate number. Now you must be thinking why this second collision is duplicate, because previously also these two pointers got collide at this point, right? But we didn't mention that this is a duplicate number. But we are saying that at the second collision, it will be a duplicate number. So you might be thinking, is it mandatory that every time at the second collision point, we will have a duplicate element? So the answer would be yes. Now next we will prove this theory with a similar structure, okay? So here you can see we have a similar structure which we got while traversing the array. So here we have a starting point, then we have a point of junction where the duplicate element lies, because due to this duplicate element we are able to get this cycle, and this is the point where the first collision occurs, okay? So what we are trying to prove here is that after first collision, when we move one of the pointer to the start point, and then when we restart the traversing with only one step movement, what we are saying is that their second point of collision will be this one, okay? That is what we are trying to prove. So let's assume these are the nodes which are having a value from array. Let's say that the distance between start node and duplicate node is x. Similarly, the distance between duplicate and collision node is a. With this assumption, we can say that at this collision point where the fast and the slow pointer collide for the first time, we can say that distance traveled by slow pointer would be x plus a. Similarly, we can say that the fast pointer at this point has traveled x plus a plus few rounds of this loop, because as we have seen in the previous slide that the fast pointer was moving 2 steps whereas the slow pointer was moving only 1 step. Then it is very obvious that when both of them were in this loop, there might be a possibility that your fast pointer is moving few more rounds than the slow pointer. Then we can simply say that the distance traveled by the fast pointer was x plus a plus nc. Nc is what? C is the length of the loop and n is the number of loop. So let's say if the length of the loop is c, then you might have completed few rounds of this loop, right? So that is the number of loop you have traversed. So we can say that the distance traveled by fast pointer is x plus a plus few rounds of this complete loop, okay? Then after the collision point, what we did, we simply moved the one of the pointer at the start point, and then we move both the pointers with only one step. And then we are saying that when these two pointers will collide for the second time, it will be at this point, and that is what we are trying to prove. So as we have already assumed that the distance between start and duplicate is x, that means both of these pointer will traverse x distance to meet at this point, right? Which we are claiming is a duplicate element. Now from this point where the duplicate value lies, from here the slope pointer has moved this distance, which is a, and from the first collision point it travels x distance. That means overall it has traveled x plus a distance to come at this point again, right? So now from this point where the duplicate value lies, the slope pointer has moved this distance, which is a, and then it has also traversed x distance. That means total x plus a distance is traversed by the slope pointer to reach at this point, right? Similarly, we know that the fast pointer was taking 2 steps while slope pointer was taking 1 step. That means the distance traveled by the fast pointer is double of this distance, which is 2 of x plus a, right? That means we can say 2 of x plus a is equal to x plus a plus nc, which we have calculated earlier, right? That distance traveled by fast pointer was x plus a plus nc, right? So we can come up with this equation, and after solving this equation, we get x plus a is equal to nc. Now from this equation we can say x plus a equal to nc, and here nc is nothing but your multiple round of this loop. That means this point where the duplicate value lies, we can call it nc, right? And after traversing a plus x distance, every time you will be at this point. Let's say if the fast pointer took only one round, then the value of n would be 1, and again you will be coming here. And if the value of n would be 2, then again after 2 of x plus a, you will be coming here. That means every time after traversing this distance, you will be at this point, which is nothing but the junction where the duplicate values lies, right? That basically proves that every time when the second collision will happen, you will get your duplicate value. I hope now the fourth approach is clear. Now we will see the time complexity of this approach, and then we will see the code for this solution. Okay, let's go back to our IntelliJ. So in this approach, we have seen that we have traversed the array only once. That means the time complexity here is order of n, right? And we have also not used any extra space. That means here the space complexity would be order of 1. So now we can say that this is the optimal solution for this problem. So I hope you have understood all these approaches, and you must have understood how to approach a problem from the very naive approach, and then you can slowly move towards the optimal solution, right? So now let's see the code for this. So here I have written this function in Kotlin. You can write it in any language. I haven't used anything different in this code. I have used basic construct of any programming language. Even if you are using C++ or Java, you can write this code. So I'll simply go through the code. So the first thing we do is we simply assign the first element to the slow and the fast pointer. So here, as you can see, I have declared the slow and the fast pointer. And in a do while loop, what I did is I moved the slow pointer with 1 step, which I have shown in the previous slides, right? Where we were using the index of the previous value, right? So here in this way you can move your slow pointer, and similarly for the fast pointer we were taking 2 steps. This is the first step, and then this is the second step. So this will move 2 steps. So in this way there will be a point where your slow pointer and fast pointer will collide for the first time, and this loop will break. Okay, and at that particular point what we were doing, we were simply moving one of the pointers. So here I am moving the fast pointer to the starting point again, and then from here what we are doing, we are simply checking if slow and fast are not equal, simply increment both the pointers. So here you can see now we are moving only 1 steps, and this will continue until second collision. That means at the end you will get the duplicate value, which we have seen already, right? We have proved that at the second collision we will have our duplicate element, and then you can simply return the value. It can be slow or fast, both will be same, right? So I have returned slow value from here. So let's run this example. So here you can see that I have taken an array and I have declared few numbers. So here if you see, we have duplicate number 9, right, which is occurring 3 times in this array. So let's run this example to see the output. So here you can see that it prints the duplicate element, which is 9, right? So I hope that is clear to you, and you must have learned something from this video. And if you are someone who is practicing competitive programming, I would suggest you to solve problem in this way instead of quickly solving a problem just by looking at any editorial or any video, right? That will not give you that much learnings. If you go in this way, you will simply learn a lot from a single problem. So if you do competitive programming by following these practices, I can assure you that you will learn faster and you will be knowing more than others. So that's all about this video. There are more videos which will be coming in this competitive programming series. So if you want to learn competitive programming and if you want to crack any coding interview, do subscribe to my channel and press that bell icon so that you get notification whenever I upload any new video. So that's it from this video. Thank you for watching.